Howdy. Science alert. Astronomers have spotted a record-breaking magnetic field in space, and it's epic. Far out in the Milky Way, roughly 22,000 light-years from Earth, a star unlike any other roars with a magnetic field force that beats anything physicists have ever seen at a whopping 1.6 billion Tesla. A pulsar called Swift J0243.6 plus 6124 smashes the previous record of around 1 billion Tesla discovered surrounding the pulsars GROJ1008 slash or 5 letters. For a bit of a context, an average negative rich magnet comes at around 0.00 Tesla. The more powerful MRI machines manage to hit around 3 Tesla. A few years ago, engineers earned a pat on the back for achieving a semi-respectable 1200 Tesla, sustaining it for a blink of just 100 microseconds. So this stands to reason that 1.6 billion Tesla is going to demand some truly mind-blowing physics. Physics? The kind only achievable by massive objects crammed into impossible volumes and spun at incredible speeds, fast enough to accelerate electrons to ridiculous velocities. I have been reading that through. You can do it as well. And they are talking about all sorts of things. Magnetics. Researchers from the Chinese Academy of Science and Sun Yat-sen University in China and the University of Tübingen in Germany subsequently analyzed the feature to calculate the energy of its electrons to peak at an astonishing 146 kiloelectron volts, blissing the 90 and 100 kiloelectron volts of the previous record holders. And yes, magnetic fields. There is no magnetic field without an electrical current, and vice versa. So they were talking about earlier here about the energy. But I didn't find the word plasma anywhere in this article. And confirms likelihood. This seem to be interesting, so I clicked on that, and it leads us to the article itself. Oxford Academic, the role of multipolar magnetic fields in pulsar magnetospheres. Magneto. Yeah, they are respecting the magnetics. And that's the abstract. I didn't read that yet. Where was it? It was quite at the beginning. Just let's have a read. We will stumble across it if you can take it. We explore the role of complex multipolar magnetic fields determining physical processes near the surface of rotation-powered pulsars. Rotation-powered pulsars. Yeah, I noticed this. I didn't notice this earlier. Rotation-powered. They are powered by their own rotation? No. It's a Birkeland current which spins. We model the actual magnetic field as the sum of global dipolar and star-central multipolar fields in configuration involving asymmetric and uniform multipolar fields. Neutral points and neutral lines exist close to the stellar surface. This might be double layers. Also, the curvature radii of magnetic field lines near the stellar surface can never be smaller than the stellar radius, even for very high or order multipolars. Consequently, such configurations are unable to provide an efficient pair creation process above pulsar polar caps. The polar caps, isn't there where the Birkeland current goes in and out? Everywhere in the whole universe? Even on Earth, where we have the northern lights, Aurora Australis, aurora borealis above the polar caps, necessary for plasma mechanisms of generation of pulsar radiation. Plasma mechanisms necessary for plasma radiation. So they say they couldn't find it. Such configurations are unable to provide an efficient pair creation process above pulsar polar caps necessary for plasma mechanisms of generation of pulsar radiation. Yeah, maybe it's a plasmoid. There's the plasma. It's a plasma ball, which has magnetic fields around it. And they are part of a massive Parkland current, which is an electromagnetic current in space, which connects us to the sun to the center of the galaxy, and our galaxy to the rest of the galaxies. Parkland currents, because there is no. Where was it? Rotation powered pulsars. No. The rotation doesn't power any pulsar. It's the C pinch which creates a plasmoid like of sphere which spins because the Parkland current is spinning. That's why we have the weather patterns on Earth we have. So we are null school. Watching Earth, wind, and let's go to the highest we can find. Let's see how it looks. It's a Parkland current. In the north, there's not much going on in the center. But it seems it's reaching the equator. Really? Oh, wow. I think that's interesting. I don't know if it has to be like that. But this is really interesting. Like all the area. The whole area. From the equator to the pole. No, that's very interesting. Let's go a bit down in height. There is just a band left at the equator. And the southern part seems to be disrupted by something. There's many volcanoes here. So they might have an influence also on those streams high up in the air, sea urchin spikes or spines and such. Let's go approximately to the center or the middle of the atmosphere. There's something going on over South America. Do we have diachotron instabilities? If it would be a perfect diachotron instability, we should have 6 of these. 1, 2, 3, 4, maybe 5. Do we see anything over here? No, nothing like that, but that's also a very interesting pattern going on here, and it sweeps up to the north. And we still have, since many weeks, this low pressure system off the coast of Portugal between St. George and Portugal. Here are the Siberian traps, and there's also something going on there since there's high winds. We have some geomagnetic activity. The sun seems to wake up. 5.9-month cycle. But as we go down to the surface, there isn't too much going on, according to null score. At least not on the northern hemisphere. No hurricane. Yeah, let's check out the south. Yeah, there's definitely something up in South America, this region. Something's going on. I don't know what. I guess something seismic, geological. Earth is alive. Earth is a. You have seen geoids with the crystal inside. Let me show you a geoid. So that's some random page. I have no idea what this page is about, but there seems to be at least one picture of a geoid. Geoids are the secondary geological formation within sedimentary and volcanic rocks. They are nearly spherical rocks having hollow cavities lined with crystals. Geoid. Earth is a alive geoid. I think there's a plasma ball inside. And there's Bertrand currents going through it. Keeps it alive. Spark of life. Like in people or things alive, there's a spark of life. And there's many layers. And there's some holes. And there might be a volcanic eruption if it breaks through. Like on this is very well visible. Can we zoom in? We can. The layering. So you are here. That's the crust. That's the water. That's the magma. And so on and so on. And every now and then you get these kind of places. And it doesn't need much. Something comes out of the ground. This is how I see things. It might be not blue, because this gel is dead. Earth is alive. It's very alive. But anyway, I forgot where I started, so I'll leave it here. Thanks.